Hello everyone. Now today we will start learning a subject name is analog electronics, and this is unit 1, lecture 1. In this lecture we will study about the scheme and syllabus of that subject. After this we will move on what is semiconductor materials, its introduction, its property. After this, we will study about the type of semiconductor materials like intrinsic and extrinsic semiconductor materials and their property. After we further move on, the classification of extrinsic semiconductor material means p-type and n-type semiconductor. So this is the contents and the outline of our presentation. According to that, we will move on. So let's start. With scheme and syllabus of that subject. Name is analog electronics. So this is the scheme. In this scheme, the analog electronics subject code is EX305. In that subject, 100 marks for the theory and 50 marks for the practical. You can see end semester 70 marks, mid-sem 20 and quiz assignment 10 marks. So this is a total 100 marks for the theory. In practical and sem 30 marks and term work as well as the lab work is 20, so total 50 marks. So this is all about the scheme. Now we will move the syllabus of that subject. Name is analog electronics. So in this subject there is a 5 unit. In unit number 1 we will learn about the semiconductor diodes, theory of p-n junction, temperature dependent and breakdown characteristics of p-n junction diode, junction capacitance, classification of the diode like Zener diode, varactor diode, tunnel diode, pin diode, LED, stand to light emitting diode, photodiode, Schottky diode, and diode application, series parallel configuration, full wave and half wave rectification, voltage multiplier circuit, and diode testing. Now we will move on to unit number 2. In unit number 2 we will study about transistor. BJT stand for bipolar junction transistor, its type and configuration, working principle, characteristics, and the reason of operation, load line biasing method, small signal analysis of transistor using H parameter, thermal runaway and thermal stability. FET stand for field effect transistor. MOSFET stand for metal oxide field effect transistor. Transistor as an amplifier, gain, bandwidth, frequency, response, etc. Now we will move on unit number 3. In this unit we will learn about the feedback amplifier oscillator. Feedback amplifier, negative feedback, voltage series, voltage shunt, current series and current shunt feedback, sinusoidal oscillator, LC oscillator, RC phase shift, Wein's ridge, crystal oscillator, power amplifier, class A, class B and C amplifier, their efficiency and power dissipation, push-pull and complementary symmetry push-pull amplifier. In unit number 4 we will study about wave shaping circuit. In this circuit, we learn switching characteristics of the diode and transistor, turn on and off time, reverse recovery time, transistor as a switch, multi-vibrator, bistable, monostable, astable multi-vibrator, clipper and clamper circuit, differential amplifier, calculation of differential, common mode gain, H parameter, bootstrapping techniques, cascade and cascade amplifier. Now we will move on last number unit, name is unit number 5. So in this unit we will learn about the operational amplifier. Inside this we will learn operational amplifier basic, practical operational amplifier circuit and characteristics, slew rate, bandwidth, offset voltage, basic current application, inverting, non-inverting amplifier, differentiator, integrator, differential amplifier, instrumentation amplifier, log and anti-log amplifier. Means we study about so many type of amplifier written in the syllabus. Voltage to current and current to voltage converter, comparator, schematic trigger, active filter, 555 timer and its application. So this slide all about the syllabus of analog electronic subjects. So today's presentation will move on semiconductor material. It's a basic introductory. So next topic is what is semiconductor material. So first question occur our mind, what is the semiconductor? So semiconductor are the material which have a conductivity between the conductor and non-conductor or insulator. It means semiconductor क्या होता है? Semiconductor ऐसे कंडक्टर्स होते हैं जिनकी कंडक्टिविटी कंडक्टर और इंसुलेटर के बीच में लाई करती है. So firstly we will study about what is the conductor. Conductor are the material which provide easily flow of current. Simple language में अगर हम बोलें तो ऐसे metals या elements जो कि current flow को आसानी से होने देते हैं उसको हम conductor बोलते हैं. Insulator which does not allowing to flow the current. ऐसे मटेरियल जो करंट फ्लो को अलाउ नहीं होने देते उनको हम इंसुलेटर बोल देते हैं. फॉर एग्जांपल वुड, लकड़ी हो गया. तो सेमीकंडक्टर की जो कंडक्टिविटी है वो इंसुलेटर एज वेल एज द कंडक्टर दोनों के बीच में होती है. सो दिस इज द डेफिनेशन. सेमीकंडक्टर आर द मटेरियल विच हैव द कंडक्टिविटी बिटवीन द कंडक्टर एंड इंसुलेटर. Another definition of the semiconductor material is the semiconductor material are those material which is act as an insulator at room temperature, and when the temperature is increased, so it is work as a conductor. This is the another definition of semiconductor material. The semiconductor can be compounds such as gallium arsenide or pure elements such as germanium and silicon. Now the example of the semiconductor: gallium arsenide, germanium and silicon are the some of the most commonly used semiconductor material. Silicon is used in electronic circuit fabrications and gallium arsenide is used in solar cell, laser diode, etc. Now, holes and electron in a semiconductor. Holes and electrons are the type of charge carrier accountable for the flow of current in semiconductor. Holes, called valence electron, are the positively charged electric charge carrier, whereas the electron are the negatively charged particle. Both electrons and holes are equal in magnitude but opposite in polarity. Next is the mobility of electrons and hole. In a semiconductor, the mobility of the electrons is higher than that of the holes. It is mainly because of their different band structure and scattering mechanism. Electrons travel in the conductor band, whereas the holes travel in valence band. This is the name of energy bands like conduction and valence band. When an electric field is applied, the holes cannot move because the size of the hole is large. We suppose the size of the holes is large compared to the electrons, so holes cannot move as freely as electrons due to their restricted movement. The elevation of electrons from their inner shell to higher cells result in the creation of the hole in a semiconductor. Since the hole experiences a stronger atomic force by the nucleus than electron, holes have lower mobility. So this is the concept of electrons and hole in semiconductor material. You can see the diagram. This is the diagram of the silicon. So you can see blue dots represent the free electrons and yellow holes in a diagram represent holes. Holes is positively charged and electrons is negatively charged. The next slide. The property of the semiconductor material. Semiconductor conduct electricity under preferable conditions or circumstances. This unique property makes it an excellent material to conduct electricity in a controlled manner as required. In earlier we discussed the another definition of the semiconductor material, like the material which is act as an insulator at room temperature, and when the temperature is increased, so it is act as a conductor. सिंपल लैंग्वेज में अगर हम इसको बोलें तो नॉर्मल रूम टेम्परेचर पे जो मटेरियल हमारे इंसुलेटर की तरह काम करते हैं और अगर टेम्परेचर हम बढ़ाते हैं तो वो कंडक्टर की तरह काम करने लगता है। ऐसे मटेरियल को हम सेमीकंडक्टर मटेरियल बोलते हैं। यही सबसे इंपॉर्टेंट प्रॉपर्टी है सेमीकंडक्टर मटेरियल की। नाउ unlike conductors, the charge carrier in semiconductor arrays only because of external energy called thermal agitation. It causes a certain number of valence electrons to cross the energy gap and jump into the conduction band, leaving an equal amount of unoccupied energy status, that is hole. Conduction due to electrons and hole are equally important. So the resistivity of the semiconductor lie between 10 to 5 to 106 ohmmeter. Conductivity of the semiconductor is 105 to 10 to 6 mho per meter. Temperature coefficient of resistance is negative, and the current flow in a semiconductor material due to electron and holes. The main reason to flow the current is free electrons and hole in a semiconductor material. Now, next topic is types of semiconductor materials. Next, the types of semiconductor materials. The semiconductors are classified into two categories. Number one is an extrinsic semiconductor material, and number two, intrinsic semiconductor material. Intrinsic semiconductor material is a pure form of semiconductor. If we can add some impurities by doping. So the material is called the extrinsic semiconductor material. Extrinsic semiconductor material are further classified into two categories: P-type semiconductor material and N-type semiconductor material. So this is a basic classification of the semiconductor material. Now, what is intrinsic semiconductor material? So an intrinsic type of semiconductor material is made to be a very pure chemically. I explained you earlier. The pure form of the semiconductor is called intrinsic semiconductor. It is made up of only a single type of elements. The conduction mechanism in case of intrinsic semiconductor, there's two figures, figure number A and figure number B. In figure A, the absence of electric field. In figure B, presence of electric field. Germanium and silicon are the most common type of intrinsic semiconductor elements. They have 4 valence electron, stand as tetravalent. They are bound to the atom by covalent bond at absolute zero temperature. When the temperature is rise due to the collision, few electrons are unbounded and become free to move through the lattice, thus creating an absence in its original position, create holes. These free electrons and holes contribute to the conduction of electricity in the semiconductor. The negative and positive charge carrier are equal in manner. It means semiconductor material में electrons और holes responsible होते हैं current flow कराने के लिए. The thermal energy is capable of ionizing a few atoms in the lattice, and hence their conductivity is less. Next, what is extrinsic semiconductor material? The conductivity of the semiconductor can be greatly improved by introducing a small number of suitable replacement atoms called impurities. The process of adding impurities atom to the pure semiconductor is called doping. Usually only one atom N107 is replaced by a dopant atom in the dopant semiconductor. An extrinsic semiconductor can be further classified into two categories: N-type semiconductor material and P-type semiconductor material. तो जो हमारे एक्सट्रिंसिक सेमीकंडक्टर मटेरियल वो मटेरियल होते हैं जो हम प्योर सिलिकॉन और जर्मेनियम में जब कोई ट्राइवेलेंट या पेंटावेलेंट इम्प्योरिटीज़ को डोपिंग के थ्रू ऐड कर देते हैं, तो ऐसे जो हमारे पास मटेरियल मिलते हैं उनको हम एक्सट्रिंसिक सेमीकंडक्टर मटेरियल बोलते हैं. और एक्सट्रिंसिक सेमीकंडक्टर मटेरियल जो है वो क्लासीफाई है टू कैटेगरी में: N-type semiconductor material and P-type semiconductor material. This is the diagram of extrinsic semiconductor material. In figure number A, N-type semiconductor material, and figure number 2, P-type semiconductor material. N-type semiconductor material, donor impurities contribute free electrons. In a P-type semiconductor material, acceptor impurities create a hole. So the next topic is What is p-type and n-type semiconductor material? So next we will study about what is n-type semiconductor material and how it is made. When a pure semiconductor, silicon or germanium, is doped by pentavalent impurities. Pentavalent impurities का मतलब ऐसे एलिमेंट जिनकी वैलेंसी 5 होती है उनको pentavalent impurities बोलते हैं. So when a pure semiconductor material is doped by the pentavalent impurities, then the 4 electrons out of the 5 valence electron bond with the 4 electrons of the germanium or silicon. The 5th electrons of the dopant is set free. Thus, the impurity atom donate a free electrons for conduction in the lattice, and it's called donor. Since the number of free electrons increase by the adding of an impurities, the negative charge carrier increase. Because the electron has negative charge, if we add the impurities, so free electrons is created. Since the number of free electrons increase by the adding of an impurities, the negative charge carrier increase. Hence, it is called the n-type semiconductor material. In an n-type semiconductor material, the majority carrier is मेजॉरिटी कैरियर वो होते हैं जो कि ज़्यादा अमाउंट में पाए जाते हैं किसी मटेरियल में, उसको हम मेजॉरिटी कैरियर बोलते हैं. माइनॉरिटी कैरियर जो कि कम अमाउंट में पाए जाते हैं. सो in a n-type semiconductor material, the majority carrier is electron and the minority carrier is hole. In n-type semiconductor material, mainly due to electrons, entirely neutral, majority carrier electron and minority carrier is hole. So this is all about the n-type semiconductor material. कैसे हम बना सकते हैं n-type को? पेंटावेलेंट इम्प्यूरिटीज को ऐड करके प्योर सिलिकॉन या जर्मेनियम में, और n-type मटेरियल में मेजॉरिटी कैरियर इलेक्ट्रॉन्स होते हैं और माइनॉरिटी कैरियर्स होल्स होते हैं. Now we will move on the next slide. Continue with n-type semiconductor. Crystal as a whole in neutral, but the donor atom become an immobile positive ions. As conduction is due to the large number of free electrons, the electrons in the n-type semiconductor are the majority carrier and holes are the minority carriers. Now the next topic is a p-type semiconductor material, how it is made and what is the majority and minority carrier of p-type semiconductor material. So when a pure semiconductor material is doped with trivalent impurities, अगर हम प्योर सिलिकॉन और जर्मेनियम में किसी ट्राइवेलेंट इम्प्यूरिटीज को ऐड कर देते हैं, उससे जो मटेरियल मिलता है उसको हम पी टाइप सेमीकंडक्टर मटेरियल बोलते हैं. वही इसमें लिखा हुआ है. When a pure semiconductor material is doped with a trivalent impurities, then the 3 valence electrons of the impurities bond with the 3 of the 4 valence electrons of the semiconductor. This leave an absence of the electrons called hole is the impurities. These impurities atom which are ready to accept bonded electrons are called acceptor. N-type material is called donor and p-type material is called acceptor. With the increase in the number of impurities, the holes called the positive charge carrier are increased. Hence, it is called the p-type semiconductor material. So the main point for the p-type semiconductor material is mainly due to hole, entirely neutral. The majority carrier in p-type semiconductor material is hole or positive charge, and the minority carrier electrons or negative charge. The next slide P-type semiconductor material continue. The crystal as a whole is neutral, but the acceptor become an immobile negative ion. As conduction is due to the large number of the holes in a P-type semiconductor material are the majority carriers and the electrons are minority carrier. So in a P-type material, the majority carrier is holes and minority carrier is electrons. So this is all about the P-type semiconductor material. In our next lecture, we will discuss about what is the p-n junction diode, its working principle, characteristics, and application of p-n junction diode. Thanks for watching the videos. Any query, any doubt, so please ask me. And thanks again for watching the video.